We've got some people here in the room as well. So my name is Jim Lake. I'm Vice President of Training and Technical Services with Viking Corporation. Today is the continuation of the training that we're doing here over the next week or so, or the next 3 days. This is sprinkler installation requirements. Basically what we're going to be doing is building on the presentation, just kind of introduction to sprinklers, but now we're going to take it to that next level and focus specifically on the installation requirements that come from Chapter 8. Basically what we're going to do is a walk through what is Chapter 8 in the standard, which is the installation rules. Now, Chapter 8 is basically divided up into, it's a couple of overview sections, and then it gets specifically into the installation requirements for each type of sprinkler. But to start with, remember the last session we were talking about, just when we were looking at the sprinklers in particular, and we said kind of that base formula of flow is Q equals K times the square root of P, and all of that, the amount of water coming out of the sprinkler it was to provide a specific density over a specific area, and that specific area or density was governed by the occupancy classification. Well, what we're going to find again is the occupancy classification also has an impact. Getting the occupancy classification correct has an impact on the installation rules as well. Because in some cases, it's going to drive maybe what type of sprinkler you can use. It's going to limit the area of operation or provide some area of operation guidance. So it's really important to kind of get the classification of the occupancy correct. That is the single most important decision that a designer or a layout technician is going to make, is an engineer. They're going to identify what the hazard classification is for that building. And the reason that it's so important is that once we decide what the hazard classification is for that building, it kind of governs many other components and limits your decisions actually in some cases as to the type of sprinklers that can be used, maybe even the type of pipe that can be used, things like that. So, I mean, we mentioned earlier, remember that we said if it was a light hazard occupancy, that, for example, that NFPA 13 says that if it's a light hazard occupancy, you have one type of sprinkler that you're limited to, okay, and that is the quick response sprinkler. Now, there's a quick response extended coverage, things like that, but you're limited to a quick response sprinkler in a light hazard occupancy in a new installation. So that's really kind of a critical point in the whole decision-making process. Is once you've decided, okay, great, we're going to use light hazard occupancy. Well, now you're limited to this particular family of sprinklers. So that being said, we also get into some other areas. We're going to see as we get out into some of the other design criteria here that once we decide on a hazard classification, it may have an impact on some of our other decisions as well.
Can I ask you a question?
Sure, you may ask many questions if you'd like.
Okay, if you design a building for a light hazard occupancy.
Correct.
Obviously, you're limited to 4 or 5 sprinkler heads that are available.
Well, there's more than that. They just need to be quick response. There's Viking produces. Yeah, Viking builds many quick response sprinklers. It's just you have to use them.
Okay, if you wanted to change the hazard at a later time, is the piping adequate to go to a, let's say, medium hazard or a high hazard? Not a high hazard.
It's a great
high hazard. Can you change out your sprinkler heads to meet a higher standard?
You don't have to. Okay, remember that you don't. An ordinary hazard group 1 or an ordinary hazard group 2, you can use quick response in there as well.
Right.
Okay,
but
so
it's not a light hazard. It wasn't built as a light hazard.
But it wasn't now. So to your one answer, you don't have to change out the sprinklers from quick response simply because you've changed out because it's a hazard classification change.
Right.
However, what you do need to look at is what was the design criteria you used. If this particular sprinkler system was designed for delivery, remember we talked about the actual delivered density this morning and 0.1 gallons per minute that was for a light hazard occupancy.
Right.
Well, if we have an ordinary hazard group 1 occupancy, that's it's 0.15. Okay, so that has a different water supply requirement. You may not have sized your piping correctly to get that amount of water out, or you may not have the right pressure to get that water out.
Okay, it's only built to the light occupancy.
Mm-hmm.
Like hazards, they're ordinary 2 or 3. So you obviously would have, your water supply would probably be your biggest
You need to.
restriction on the whole system, because they're not going to put a larger main or anything
Right.
like that if they don't need to.
You would need to evaluate a couple of things. It's not just the water supply, because it's also spacing.
Right,
Okay.
right.
Hazard classification, increasing the hazard classification also may impact the restrictions on the area of operation. May limit you to say 130 square feet if it's a standard sprinkler. Okay, whereas with light hazard you can go up greater than that. Okay, so we'll take a look. We'll show you how that plays in, and you'll see that it's not just about the water supply itself. It's also the appropriate spacing of the sprinklers.
Both
So-
distance on the line and lines themselves.
So what usually happens, if there's going to be any question of a lot of times, what designers will do or engineers might do on a building like this where they're not entirely sure where it's going to go, is sometimes you may consider over designing. Go with the 0.15 over that particular hazard area, or so that you can fluctuate down. It's a lot easier to start with greater and then have light hazard
Right,
underneath.
so you will pre-engineer
Yeah.
it for them too.
Right.
With the higher density.
Yes.
Okay. No
So that may be an option. However, you got to also remember it's money. It's all about getting that system in there for the least cost. So that's really important. I mean, it's really kind of critical that we see that. So when we look at the guidelines in Chapter 8, now again, we're only spending a couple hours looking at them, so it's going to be sort of an express train through some of these requirements. We're not going to dive too deep into them right away, but we're going to kind of show you, kind of as we get into each of the types of sprinklers, just how things kind of change just a little bit in the requirements, and how you just can't pick one type of sprinkler and go with it and say, all right, this is going to be my go-to for the whole building, or we can't just have the kind of flexibility sometimes that we have, as we've discussed earlier, as we discussed just now. So what we're going to look for in the next couple hours here is to be able to describe a process for selecting sprinklers for installation. We've already started that. All right, we've already started into that by saying, what's the hazard classification? So the process begins with getting the hazard classification right. It's going to be different for an office building than it is for the kitchen in a restaurant. You're going to have a different hazard classification. And you're going to have a lot of buildings that have multiple hazard classifications. So how do we deal with that? When we have multiple hazard classifications in a building, like a hospital, lots of different places, lots of different hazard classifications in there. Or an airport terminal, same thing. Everything from light hazard to extra hazards that you could wind up with in a airport terminal. So that's going to be the start of the process. How do we describe the process for selecting those sprinklers and installation? We also want to identify the specific installation requirements for various types of sprinklers. That's the title of the seminar, so that's what we're going to talk about, those installations. And then discuss the importance of spray pattern obstructions, because not only as we look at the rules for what type of sprinklers we can use, the installation requirements for various types, what we're going to be trying to do, remember we showed you earlier, in the previous session, we showed you those spray patterns. We showed you the videos of the nice spray patterns developing, and kind of how the sprinkler covered that particular area with spray at a specific density. Well, we know that we're not always going to have a nice flat smooth ceiling up there, allowing us to create a specific spray pattern, an uninhibited spray pattern. So in certain areas, we're going to need to learn how to deal with obstructions to the spray pattern, and remember that the type of sprinkler that we're considering using is going to have different rules about avoiding the obstructions. So it's important to understand that when we get into those particular areas that we focus mainly on what those requirements are for that particular sprinkler, because they're going to vary depending on the type. So let's start off with the standard. This is NFPA 13. It is the specific standard for the installation of sprinklers. It's been around for over 100 years. It's been and changing every 3 years. So the requirements in NFPA 13 kind of flip around. Every now and again, you'll change some pretty significant ones. As I said in the previous session, we talked about that one in 2001 that said all light hazard occupancies will now have quick response sprinklers in them. That was a big change. There was a big change in the document, and so since then we've been working with that kind of that kind of rule. So just over the years, every 3 years it gets changed. And basically the basic requirements that you find in NFPA 13, the general rule, the goal of NFPA 13 basically is sprinkler everything. That's the rule. Sprinkler everything in the building. No exclusions, no special areas, anything. Except where they are permitted to be omitted by the standard. And there are a few places, and that's going to be basically our next session. We're going to be talking about where we talk about concealed spaces and other areas where sprinklers can be omitted. But so there are spaces up above ceilings, non-combustible concealed spaces up above ceiling. We can eliminate sprinklers there. Some small rooms, small areas, closets, things like that. Depending on the occupancy, we may be able to eliminate. The standard may allow us to eliminate sprinklers there as well. So how we're going to deviate some of these installation requirements based on the testing results, and clearance between sprinklers and ceilings exceeding the maximums specified in this standard are permitted, again, based on testing. So we can get up to larger areas of operation, perhaps, as long as we have tested them out and proven that the sprinkler will operate. So primarily with this basic requirement in section 8.1 of the standard, we break it down into a couple of exceptions. Where the standard allows us to omit the sprinklers, and then it comes across a couple of interesting ones at the end. Furniture such as portable wardrobe units, cabinets, trophy cases, and similar features not intended for occupancy, they don't require sprinklers in them either. You can see by the requirements as they're written in the standard that somebody was trying to actually enforce putting sprinklers in a trophy case at one point. You just know that's what happened, because the rule says we had to write a rule that said you don't have to do that. Okay, so somebody was trying to put a sprinkler in here. Somebody was trying to enforce it. No, you got to put sprinklers everywhere just in case. All right. So the basic requirements are no, you don't have to put a sprinkler there either. Now, another issue that came up recently over the past couple of years, as far as installation is concerned, it's a concept of what we call shadow areas. Now, shadow areas are actually described as areas where it doesn't appear, if you were looking at it on paper, it appears as though you're not getting any water spray in that particular area. So let's take a look at this particular space here. Now this is an actual, I was in a hotel elevator vestibule area up in Tallahassee, actually. And I was standing in the hotel vestibule, and the elevator doors are over here, and there's this sprinkler right here. Okay, it's a sidewall sprinkler. Okay, and it was on the wall jutted out in this particular space here. So if I've got a sidewall sprinkler, where's the spray pattern going in the sidewall sprinkler? From here, okay, over, right? Now on paper, what does this look like here?
Shadow area.
A space that's not going to get any water in. So sure enough, I looked around the corner. Now this is only about 15 inches deep right here. Okay, this is not a big not a big 15 maybe by 2 feet. And sure enough, there was a sprinkler there. Now, how much of the floor area is this sprinkler actually protecting?
Hold on.
That right there.
Everything it reaches.
Right. Well, yeah, but this has already got everything else. This thing really is only going to protect this. Now, why did it get required to be put there? Why did that sprinkler get required to be put there?
Unprotected.
Yeah, it looks like on paper that it's unprotected. What we also know about that, though, is it's not really unprotected, because the way that the water droplets actually interact with the air when the spray pattern comes out, there's an eddying effect here too, that it'll actually get back in there. The other thing is that nowhere in the standard ever did it say that you have to get 0.1 or the density over the entire area of that it's required. It never really said anything about little shadow areas like this. In fact, we've had obstruction rules in the standard for decades. Okay, understanding that in some cases you got obstructions to spray pattern that might actually affect the overall the spray pattern getting to a particular spot.
What if your fire started there?
What if the fire started there? Okay, it's a great question, because that's the thing that drives this entire discussion. Okay, so what's the main goal of an NFPA 13 system?
Control the fire.
Control the fire until the fire department shows up. It's fire control. Okay, and that's really a critical thought process that gets missed when we start overanalyzing shadow spaces, shadow areas. Okay, when we start saying, oh my God, there could be a fire that starts there, and there could, who knows? But if what's the fire going to do? It's going to move out here. Eventually, it's going to activate this sprinkler, and what's that sprinkler going to do? It's going to control it.
I was thinking that when I
It's a
asked
big
you,
water
I
shelter.
had to ask just to
Yeah.
Yeah, you're
right.
right.
No.
Same thing if you have a small room or a certain size room, if it's under that square footage,
Right.
you would have a room with a door that it wouldn't be sprinkled anyway.
Right.
So
If I have a small space, a closet in a hospital, small closets in hospitals don't have to, small bathrooms in certain occupancies don't have to 55. We're saying you don't even have to put sprinklers in.
That's where that small
Right.
window comes in, basically,
Yeah.
I guess.
Yes.
And so as long as the square footage are, now that might be just like a soffit that's up high,
Sure.
where at the bottom it goes in it. So
It could also be that this is just a soft. This one actually went floor to ceiling. This one was weird. It was an architectural feature that created this little space behind it, which was just kind of odd. Now, other people, other times we're gonna look at obstruction rules, and one of the obstructions we're gonna look at is what if I've got a sprinkler in this room and I've got a pillar in this room. Can I protect this room with one sprinkler if I get the appropriate spacing? Let's just maybe a 20 by 20 room. We'll figure it out. If I put, if this is just a 20 by 20 room, then I could theoretically put one sprinkler in here and protect the entire room. But what if I had a column in this room? Okay, it's spraying over here, and okay, so I've got this. The problem was people were saying, oh no, you're creating a shadow area in that space, so we got to put another sprinkler here. No, that's why we have obstruction rules. That's why part of this presentation is kind of looking at the obstruction rules that we have, because we've known about them, and we deliver and we detail this, and it's why, because the concept of fire control in most of our systems, most of the systems we design, is very important, so that we don't have to be putting sprinklers behind every pole. All right? It's only when you get to early suppression fast response sprinklers, ESFR, where their operation, their goal in their operation is actually suppression, that you get to a different level of obstruction rules, and it's much stricter on ESFR sprinklers, mainly because they have a different goal. They have a different objective they're trying to get to. All right, so in this case, so it got to the point where the language was added to NFPA 13 in the annex material, specifically calling out and addressing shadow areas. because the technical committee couldn't kind of come to an agreement on as to how to handle this, and it became really apparent that something needed to be said, because enforcers were starting to look around and say, I think we need to put a sprinkler on that side of the post or on that side of the pole. And it clearly states that where small shadowed areas are formed on the floor adjacent to their architectural features, these shadow areas are purely on paper. Okay, and then we get into places like electrical equipment, not electrical equipment rooms, but electrical equipment period. Big, huge equipment, air handlers, things like that just get placed in large spaces within buildings. And once again, we got an exception that says you don't have to drop sprinklers down into those locations. Okay, so as we get out into chapter 8 now, we're going to get specifically out into the selection of the sprinklers, section 8.4. Section 8.4 then goes into a couple of kind of overview of when we're picking standard spray pendant, the application of those, when we're picking sidewall spray sprinklers can be used, for example, in light hazard occupancies with smooth flat ceilings, ordinary hazard occupancies with smooth flat ceilings, and to protect areas below overhead doors. So you heard a couple of things there, I hope. Smooth flat ceiling. So light hazard and ordinary hazard occupancies, sidewall sprinklers. You can't use them in extra hazard, and you can't use them in obstructed ceilings. Okay, you can use them in under flat smooth ceilings like you got right here. So that's a limitation. All right. So extended coverage sprinklers, that gets into section 8.4, gets into a couple of different modifying requirements as to where you can actually use them, limiting your selection. If I've got an extra hazard occupancy, it limits my selection to upright and pendants. I can't use sidewalls. Then positioning the sprinkler then becomes a section 8.5. We're going to talk about sprinkler positioning, spacing, and location. So section 8.5 and 8.6 provide us this 8.5 provides us this general positioning and spacing rules, and then we get into the specifics of each particular sprinkler. So the general rules then for positioning, spacing, location, as detailed in section 8.5, we get into section 8.5, some general requirements. Then we talk a little bit about protection area per sprinkler. So general rules on exactly where that protection area per sprinkler, how you calculate that protection area per sprinkler. Some general rules on sprinkler spacing, deflector position, obstructions to discharge, clearance to storage, and when you run into skylights. Okay, when we actually have an issue with skylights. So the general requirements then provide protection area that is consistent with the overall objectives, whether it's suppression or control. Or if it's residential, maybe there's a life safety mode in there as well. Section applies to all sprinkler types unless modified by more restrictive requirements in section 8.6 through 8.12. So these rules that we're going to talk about in 8.5, they apply to everything unless they get modified in those sections. Now in those 7 sections, those are the specific other types of sprinklers. So when we're determining the sprinkler area of operation, what's important to note is kind of what we call the S times L calculation. So along the branch lines, choose larger of the distance between sprinklers, twice the distance to the wall or obstruction, and this is the S dimension. So my S dimension is right here. S is distance between sprinklers. Okay? And then between the lines, L is the distance between the branch lines and whichever is greater, twice the distance to the wall or the obstruction. So what this needs to be here is L, and then we measure to the wall, and that's left. If the wall is the edge of the picture here, then obviously these sprinklers are less than that distance, less than half that distance to the wall. So we can use, in this case, S times L. And then the area of coverage then becomes area A sub S is the sprinkler, area of the sprinkler equals S times L. Now, sometimes we have sprinklers that are moved off of, or there's an arm over off of the branch line. And in this particular case here, you're measuring the distance, the S and L, or the L distance right here. You measure it from sprinkler to sprinkler, not from line to line. Okay, if this is if I've got some arm overs here, then the distance, this area, this sprinkler's covering is actually from here to here, or half of that distance, or half of that distance.
That's the branch line.
Yeah, not to the line
To
itself.
the heads,
Right.
or the drop.
Always looking at the heads. That's what's bringing the water. That's what's covering the area on the floor, not the piping. So sprinkler spacing then becomes, you know, the general rules for this become, we need to look at the maximum distance between sprinklers, because we don't want to space our sprinklers so thin, obviously, that we've got true dry spots that never get any water. Okay, so each type of sprinkler will have a maximum distance between sprinklers. It will also have a minimum distance between sprinklers, okay, or a maximum distance to the walls, and that's usually going to be half the distance between the sprinklers. Okay, so this one here, maximum distance to the walls is usually half, well, it's half of what this distance is. Then you have a minimum distance to the walls, because we just want to make sure that the sprinklers are going to operate, and you need to make sure that there is air moving around that sprinkler to get the heat to the sprinkler. So minimum distance to the wall is going to be crucial. And then minimum distance between sprinklers, because one of the problems is with getting sprinklers too close is that the first sprinkler that operates does what? It starts to spray on the other sprinklers around it if they're too close. What that does is it causes an effect called cold soldering, and what will happen here is the other sprinklers won't operate, ever. And then the fire gets a little too big, and then it gets beyond your area, the area of initial sprinkler operation. There's that maximum distance between sprinklers, same thing. Okay, we're concerned about measuring that, and it's sprinkler to sprinkler. All right, right down the line. Sprinkler to wall, we're measuring wall to sprinkler. Half the distance usually of what the maximum spacing is for that sprinkler. All right, minimum distance, yeah, we gotta be really careful with this one. All right, we just gotta be really careful with something, and where this really becomes an issue is not so much when in the original installation, but it's when somebody retrofits space into the building. Take an old warehouse or an old mill building or some old structure, and they say, we're going to create office space in here, we're going to do loft apartments in here or something like that, and bang, they just start throwing walls up everywhere. Well, so the problem here is that this particular sprinkler, while it's very, very close and probably too close to the wall for anything, what do we have on the other side of that wall? You got a sprinkler that's probably 15 feet off of that wall, or 10 feet off of that wall, or definitely not half of the distance it's supposed to, the half of S or half of L.
Also, that's in a shadow zone, like we.
Yes, this is too close. This is one of those things, like a smoke alarm, where it's going to be very difficult for heat to collect in here. Okay, so that's why minimum distances are important. Minimum distances need to be maintained, as I said, to eliminate wetting of that particular sprinkler. So here we have 2 by 2 ceiling tiles, just like we got in here, and I've got this one here and I got that one there. So basically I've got a sprinkler here and a sprinkler here. Too close. Okay, that's one of these is never going to go off. Okay, so those are the general rules. Now sprinkler deflector position is mostly an issue when it comes to distance from the ceiling. And distance from the ceiling is going to have a couple of different things that we need to look at, mainly depending on the type of ceiling that we're looking at. Is it unobstructed construction or obstructed construction? Because if I've got an old mill type construction where I've got large beams here and another large beam here, deflector position's got to get up into that pocket and only be a certain distance below the ceiling. And that's going to vary a little bit depending on depending on the installation rules. Okay, so that might vary just a little bit. So now we've got a corrugated metal deck. And in this case here, we're measuring our distance down below the corrugated metal deck. All right? So we got to pay attention to the depth here. If it's less than, I think, 3 inches here to here, I think it's 3, then we can treat that as a monolithic ceiling. If it's greater than that, then we measure the sprinkler distance to up in here. I think it's 3. Okay? Okay. So insulation becomes another issue that we need to be concerned about. All right, so if I've got insulation on my roof, and I've run it flat and it's rigid insulation, then I can measure that distance right to the underside of the insulation. I don't have to go all the way up to the roof line. I'm not measuring it through the insulation. This is behaving like the ceiling line. The problem is, one of the other ways that we can install insulation is basically draping it or sagging it over the tops of these components, okay? Bar joist construction or what have you. All right, so now we have to pay attention to the depth of the sag. 6-inch maximum depth of the sag. And if that's the case, then that's the maximum, then I can go only to, as long as I do this, I can go 1 to 12, but I can measure it to halfway up the sag. I can stop it right there. If I've got a deeper sag than the 6-inch max, then I measure it all the way up to the top.
If you got it deeper?
Yes. If this comes down further, then I need to measure my distance of sprinkler all the way up to here, and it can't go more than 12 inches. That's the key. Okay? So keeping this sag at 6 inches is kind of crucial. Otherwise, I've got to push this thing up closer to the ceiling line, and I may have to even start putting sprinklers like right up in this sag area in order to make it, in order to get it to that particular 1 to 12 distance.
Closer to 24 inches.
Pardon?
Sprinklers closer to 24 inches.
24 inches where?
From the ceiling. 24-inch gap from the ceiling.
There's got to be a 24-inch gap between that and the ceiling? No. No, it's not 24, but it doesn't have to be. Okay, that's what I'm saying. There's a maximum that it can be in some cases. Flat smooth ceilings, I think, are 22. Okay, so what with flat smooth ceilings, you're going to get a collection, and it's going to come down in a monolithic way and operate your sprinkler. When I've got things like this, the heat's going to collect in these pockets. And it's going to continue to collect in these pockets. Okay, and that's going to slow things down for it, because what we want it to do is get down to here and operate the sprinkler. So if it's doing a lot of this, then it's going to be a while before we do that. So we got to get the sprinkler. We got to get the sprinkler up closer to that ceiling line, so it's going to be exposed to the heat faster. Now, deflector orientation becomes a bit of an issue as well. We got to remember that, as we talked about earlier, there's upright pendant sidewall sprinklers. Okay? So when you have upright pendant and sidewall sprinklers, you don't always have a horizontal roof. Sometimes you have a pitched ceiling line, right? So that pitched ceiling line, then, we don't install the sprinklers in a straight up and down. We are required to install the sprinklers, along the pitch of the roof.
Same orientation of the
Yeah, the deflector is in the same orientation. Now, if I've got a sidewall sprinkler, that same thing happens. That sidewall sprinkler doesn't spray straight out. We tilt that sidewall sprinkler so it's spraying down the pitch of the roof. Now, one of the things that we need to take particular notice of is obstructions to our spray pattern. Potential obstructions, whether they're continuous or non-continuous, they're a sign, they're a continuous, maybe a beam, lighting fixtures, piping, things like that, could be considered obstructions to our sprinklers. each one of these sprinklers, each one of our different sprinklers approaches these obstructions in a slightly different way depending on how their spray pattern is developed. Sidewall or pendant or an upright. So let's take a look at the obstruction rules here, and this is where in each of the sections within Chapter 8, within each of the sprinklers, we're going to talk about this area where we have the, within 18 inches of the sprinkler, there's my sprinkler, 18 inches, a plane 18 inches down from the sprinkler, has a specific set of rules in section 8.5.5.2 that are an obstruction to spray pattern development. In other words, any obstruction, beam, light fixture, anything up in this space is going to obstruct the spray pattern from even developing. Okay? So 8.5.5.2 comes up and says that you're going to have to pay attention to these. All right? Not that they're not going to exist, but we have to have some specific rules on obstructions to spray pattern development. Because remember, the whole goal is to get all the water coming out of that sprinkler, all of it down on the floor. That's what we want. We know that's not always reality. So the next part is 4 feet down in this zone here, everything in this zone is what we call an obstruction to the spray pattern reaching the base of the fire. Slightly different rules that come into here for each of these sprinklers. All right, in other words, the spray pattern is fully developed within the 18-inch plane. It's fully developed, it's going. Now, we've got this 48-inch plane is anything that's in here could prohibit it from getting to the floor. And that's a different set of rules that we're going to engage with. So, obstructions can be continuous or non-continuous, greater than 18 inches or I'm sorry, this is just kind of repeating what we did earlier. Less than or equal to 18 inches need to comply with 8.5.5.2. Continuous or non-continuous in a horizontal plane greater than 18 inches below the deflector need to go to 8.5.5.3. Now in some cases, and this is one of those things where I said earlier, remember I read out specifically the rules about, the general rules about sidewall sprinklers. And we said you can put them under what? We can put it under flat, smooth ceilings, right? And light and ordinary hazard occupancies. And then it is to protect areas below overhead doors. Specifically right here. So these things look like they're really far down from the ceiling line, and that's true that they are. But once I open these overhead doors, what's obstructed? All my ceiling sprinklers are now obstructed from above. So what we've done is to create protection, because probably most of the day these doors are going to be open, all right? Now I do have protection underneath there. Because see how they extend actually under the railing of the door. So they're actually under that door.
That garage door becomes your ceiling.
Pardon?
That garage door becomes your ceiling, basically.
Yes, that's right. It becomes the ceiling. It becomes that spot that collects it. Yeah.
At that point, it doesn't matter if you have a closer one, a sprinkler head, and the other one.
You mean because these are so close?
Yeah.
I mean, yeah. These.
Those
Yeah,
are
but-
sidewalls,
Yeah.
basically.
Yeah. Well, that's the best answer to that is these are sidewalls, so they're both spraying in opposite direction. One's not going to spray on the other. The big challenge might be is if you get one that's real close to the bottom of one, you might get them both operating at the same time. But again, it's better than having none of them operate because you've got this big 10-foot obstruction. False ceiling basically is what you put in, is what you've opened up to.
Because most doors are
Yep.
8 to
My
10 foot wide.
question is that the branch lane is you can have it closer. It's gonna be it's gonna work when the door is open
Right.
below.
Yep.
But I'm saying the
Your
distance doesn't matter.
No, because if these are closed, what sprinklers are going to provide the protection? The ceiling sprinklers will, and we're not even going to rely on these to do it. It doesn't matter if these get wet from the other sprinklers because we're not relying on these to operate in that case. Okay, only when the doors are open.
Yeah.
Okay, so clearance to storage then becomes this measurement, again, down below, that's why we have this rule that says keep all your storage 18 inches below your sprinkler, okay? And for ESFR sprinklers, it's 36 inches. It's twice this is where our storage has to be.
That's what I was looking to earlier, I think
Oh, okay.
I asked about the low ceiling, but it's below the storage, yeah.
Right. So we measure from the deflector down to the storage, and this is where we've got to keep our, and this is a huge problem. Anytime you guys fire inspectors going, when I was a fire inspector going in, it's like, oh my gosh, yeah, it's within 18 inches. And you knew as soon as you were walking off, they'll say, yes, sir, we're going to take it down. Boom, you knew as soon as you were walking away. You could come in after lunch and be right back up there.
Shoe stores are the worst, they'll
Yeah.
box.
Oh yeah, shoe stores. Now the only big difference is that you can have it on the wall. You can go to the ceiling. You can go to the ceiling with your storage on the wall. Because remember, this 18 inches is spray pattern development. Well, if my spray pattern is not trying to get any further than the other side, it's not trying to get to the other side of the wall, then this does not obstruct spray pattern development any more than a wall would.
Racks in here,
Yeah. If it's out here, you got a problem.
again.
Yeah. Okay. So standard specifies anything greater, 18 inches, and that's ESFR. It goes greater. Special sprinklers like ESFRs and others might be listed. Now pay attention to the listing also of each of these sprinklers, because there may be 36 inches there, large, and unless they've gone through some sort of large-scale testing in which gets it back to 18 inches. So again, we got a couple of modifiers of this particular rule. All right, skylights and similar ceiling pockets. One of the things that we'll find in particular in the and we'll wait on a larger conversation of this, but mainly because we'll talk about it when we talk about standard spray sprinklers and such. But the deal here is that skylights behave like those sags in the insulation. Okay, they're a heat sink, and we need heat to operate our sprinklers. So basically, the requirement is, or the permission is, sprinklers can be omitted from skylights as long as they don't exceed 32 square feet, regardless of the hazard classification. And as long as they're separated 10 feet horizontally from any other unprotected skylights or ceiling pockets. And skylights may even have plastic covers over them to create just a light arrangement, a light fixture. So again, this is important that this 32 square feet, 3 square meters, regardless of hazard classification. And we're going to talk about ceiling pockets a little bit later as a little bit different architectural feature when it comes to light hazard occupancies. All right, so now let's get into specifically the installation requirements for each of the individual sprinklers or sprinkler types. Now this is where, remember, we said that that you follow the rules, except where 8.6 through 8.12 modify that. And each one of these now is all the rules for the installation of standard spray pendant and upright sprinklers are found in 8.6. So you're applying all the rules before that, 8.1 through 8.5, all those general rules, and then you apply standard spray pendant and upright. Not sideway, but sidewall sprinklers, that should be changed. Extended coverage sidewall, residential CMSA, and early suppression fast response. Those are the ones that we have in the standard right now. I will tell you that there are certain types of sprinklers out right now that aren't covered in here. One of them that we're going to talk about on Thursday deals with interstitial spaces, the protection of interstitial space. All right, and the challenges that come along with that and developing, or attic sprinklers. They're not here, okay? They're not in this list anywhere. They have special installation rules that come along with their listing, with the way they were tested. So we're not going necessarily, when you're protecting an attic, you're not going to NFPA 13 per se. You're using 13 as the base rules, but then you're following the specific listing rules for those sprinklers in those areas. Each of the sprinkler requirements is, each of the sections is then broken out into specific sections, all in the same order. So whether it's sidewall or standard spray pendant and upright, ESFR, whatever it is, you're going with general requirements in point 1, determination of protection area, point 2, sprinkler spacing, deflector position. It's all the same, depending on what sprinkler you're using and how it all sets out. So upright and pendant sprinklers then, here once again, we have to get into the protection areas of maximum space for light hazard. So remember I told you that got light hazard occupancies, standard spray pendant and upright sprinklers. We got to know what that occupancy classification is because it's going to have an impact on the area of operation, that maximum area of operation. And so that becomes, in certain areas, non-combustible, unobstructed construction. You can go up to 225 square feet, whereas you're down to combustible concealed spaces in all areas, you're down to 120 square feet. Or combustible obstructed members, this is not concealed, less than 3 feet on center, you're down to 130. So you can be between 225 and 130 just on the listing. Okay, just without the listing, you can get up to 220 square feet. Now keep in mind also that with special listing, you can get up to 400 square feet. You can go up to almost twice that size in area. And I asked the group earlier, why would you use extended coverage sprinklers as opposed to standard? And why would you want to double your area of operation?
Less money and
Yeah.
get more coverage.
Fewer sprinklers.
Yeah.
Fewer sprinklers installed usually means a less expensive system. The challenge is that in order to get that extended coverage, you're going to probably need to have greater pressure. Okay, so it's not just a free-for-all. I mean, otherwise everybody be doing it. Okay, but it is one that definitely does get people's attention of saying, oh, all right, I can use this here. And just because permission is given here to go to 225, make sure that you're comparing that with the sprinkler's listing. Make sure that you know that sprinkler is capable of delivering out to that particular distance and what the pressures are. Again, that's going to change. The K factor is not going to change on that sprinkler. So you got to, in order to get the appropriate flow, to get the appropriate coverage, you got to get the appropriate pressure coming out. Okay. Once again, we talked, going back to here, you see that this was a lot of non-combustible unobstructed construction or obstructed construction. Well, this is what we're talking about here. This is obstructed construction, solid beam members interrupting the flow of heat along the ceiling line. Here's my ceiling line. And so each time that this particular, if I get a fire over here, it's got to come over, fill up this, come over, fill up that, slows things down. So you're going to see in an obstructed construction, you've got, well, let's see, non-combustible unobstructed, 225 per sprinkler, non-combustible hydraulically calculated, 225, obstructed, it didn't have any impact there at all. All right, combustible unobstructed, if we get into combustible unobstructed, then we're at 130 square feet. Combustible obstructed, 160, as long as we have 3 feet or more on center. So what it does is it's going to impact the overall area of operation per sprinkler, as opposed to unobstructed construction, which we have over here in the bar joist construction. We're going to see that you can have greater area in those spaces. So now let's go up to ordinary hazard occupancies. Now remember, in light hazard, we had all those choices, obstructed or unobstructed. This is easy. 130 square feet, period, end of story. Unless it's listed for something greater than that. Ordinary hazard, you got, that's it. And you go up to the really high challenge fires, and in the extra hazards, hydraulically calculated, if you've got a density greater than 0.25, you're down to 100 square feet. Otherwise, you're at 130 square feet. Okay, so 130 becomes the number outside of light hazard. Now, in some cases, we may run into a room that is particularly small. It's too it's too small to, I mean, it's kind of inefficient to get 2 lines in there to protect all, it's overkill to put 2 lines of sprinklers in a given area. And the distances between, and sprinklers are permitted to be located not more than 9 feet. So when we've gone from 7.5, you get a 15-foot spacing, you can go 7.5, but you can get all the way up to 9 feet off of one wall, as long as you comply there. The distance between the sprinklers and the maximum areas limitations still apply, and this is what we call the small room rule. Okay, so in order to comply with the small room rule, it's light hazard occupancy. Okay, so you can't use this for ordinary. Unobstructed construction. It's got to be a room like this. Floor areas not exceeding 800 square feet. Yeah, pretty sure that's this room. Each wall can have openings in them with an 8-inch minimum lintel depth. So you don't even need a door necessarily there, the total width. And a single opening can be 3 feet or less without a lintel period. So I could have one door out of here without a lintel at all. And I can comply, that's the small room definition. So if I don't comply with, if I miss one of the units in here, one of these defining factors of a small room, I can't use this rule. Okay, this one back here that says small rooms, 9 feet off of one wall. So let's apply this in this case here. What I've got is a light hazard occupancy, smooth flat horizontal ceiling. Area per sprinkler 40 by 15 divided by 3 is 200 square feet per sprinkler. 200 square feet per sprinkler. Is that permitted? Yep. By virtue of the area of operation, I can go up to 225. So each sprinkler is covering that. Now, because I may have, I don't know, up above the ceiling line, I can't get the sprinkler center of the room. I can't get the sprinkler system center of the room. Okay, maybe I've got ductwork, maybe I've got something going on that I can't get up there. I have to push that sprinkler line off to the side. What this small room rule is saying is that in a room like this, as long as it meets the definition of a small room, I can move that sprinkler 9 feet off of one wall. I can't have it 9 feet off of both, but I can move it 9 feet off of one. All right? As long as I comply with all the other rules governing right back here on the small room rule.
Why is that the lintel depth so important?
The lintel depth is important because what does a lintel do at the ceiling line?
Traps the heat.
Collects the heat. So what we don't want is a whole lot of this heat escaping the room where it's not being collected. Okay? So remember, by virtue of the fact that we've got a sprinkler that's 1.5 feet further away from the wall, if we get a fire starting over here, what's that going to do to the operation time? It's going to slow it down a little bit.
Oh, slow it down.
Yeah, because it's not going to respond as quickly. It's you got a standard, or actually you would have a quick response sprinkler, but it's going to slow it down a little bit. Okay, and that's why we say, all the openings except one 3-foot opening has to have a lintel, because we want to collect it up at that level, and not let the heat escape.
Would anybody design this for a room where you have a sprinkler head 3 feet off the wall when you
Sure.
kick it over?
Sure. I mean, would you have to? No, you could. You don't have to. This is just an example.
This is, okay.
Yeah, 7 feet off of that wall.
Right.
Maybe 3 feet off.
Normally though, if you were to design that room, you would center them potential based on ceiling lights, ductwork.
Yeah,
things like that.
potentially. But what you've got here, more importantly, is you got 15 between each of these. So symmetry is, putting the sprinklers in the right location can also affect the aesthetics of the room too. I mean, you'd be surprised what you notice.
Normally sprinklers are in before most of the other stuff. This would be a remodel probably, right?
Well, look, don't think that we always get in before the other stuff either. I mean, how many? I'll guarantee I can walk out over into that design room, and each one of them will parade in here with a story about how those tin knockers came in, and that was supposed to get this in here, and all of a sudden, no, it moved.
Yeah.
Or the tin knockers told the designer, told the mechanical engineer, no, it's got to be I got to have those lights here,
Centered, yeah.
or I've got to have this centered here. It's got to be exactly that. So Everybody else has got
Last
to move.
in, yeah, last
Everybody
in,
else has
yeah.
got to move. Fire protection,
Yeah.
heck with it, just move it over a little bit. Fortunately, we can be that flexible. Okay, so minimum distance between sprinklers, not less than 6 feet apart. That's a general rule for standard spray, pendant and upright sprinklers. If you're going to get closer than that, we do permit, standard does permit baffling, all right? Baffles between the sprinklers in this particular area. Now remember, standard spray, pendant and upright we're talking about. We're not talking about ESFR or anything like that, where baffles aren't permitted.
Well, like that other picture you had where you had the mill constructed where
Yeah.
the beams are in there.
Right.
Every void could have one in theory.
In theory, yeah. Well, and in that particular case there, every unit is one. So you're gonna wind up in a situation like that where you've got that deep, you're putting sprinklers in each of them. Yeah, that becomes the big problem, the big challenge with obstructed construction like that. You wind up with a lot of sprinklers way up into the area. Now that it obstructs the spray pattern within that 18 inches. So you have to have them in each unit, right? Okay. Deflector position, unobstructed construction, 1 to 12 inches. Unobstructed, 1 to 12 inches below the ceiling. Doesn't apply to concealed and recessed or flush type sprinklers. So the unobstructed deflector distance below the ceiling, 1 to 12. Obviously, with our concealed and recessed and flush types, they're in the ceiling. So that 1 inch to 12 inch doesn't apply. So unobstructed construction, flat smooth ceiling, 1 to 12, I can be below that. Doesn't apply to concealed. So once again, what defines unobstructed or obstructed is the distance between the obstruction. Greater than 7 feet 6 inches, we call it unobstructed construction. Up to 7 foot 6, it's considered obstructed construction. Okay? So if you were looking at this, you can just write it in. This is obstructed construction, that's unobstructed construction. Now, sometimes we also have to look at our sprinklers and determine how they're spaced in relation to a stepped ceiling. Okay? So if in this particular case the standard says that if this particular step is less than 36 inches or less, then we can treat it kind of like a flat ceiling. Okay, we can just spread the S distance between this sprinkler and this sprinkler. The S distance is 15 and whatever it is. We don't have to worry about it. However, if it's greater than 36 inches, we treat this thing like a wall going both ways. All right, because it interrupts the flow of the heat sufficiently that we want to make sure that we're not looking at it, that we're applying. So this becomes half of S going this way and half of S going that way. The sprinklers are limited to that. See, because back here, I can move these, I could have this here and this much further down the ceiling, okay? By creating it that way. That's the way you gotta look at it. With this next one, I'm going here. All right, it's one wall. I'm limited in how far they'll go apart. All right, similar issue goes in here when we come to obstructed construction. Maximum, as I said earlier, 22 inches from the ceiling, but also correspondingly, it is 1 to 6 inches below the bottom of the obstructing construction of the bottom piece of the structural member. Okay, so you don't just get 22 inches of depth. It also has to be 1 to 6 between below the bottom of the obstruction. You can't be down 8 inches down here, even though you're still 22 up above, to the ceiling up above. Now, if you're going to, and that's just if you're going to put sprinklers in this, you're going to put sprinklers down below. Now you could put sprinklers up on the same level. That's one of the things that they could have done with that type of construction. One of the things you can do is put your deflector right up at the same level as the bottom of the obstruction. Now you've got 22 inches going all the way up, and you're still below, you don't necessarily, you're still below that line. But again, it's so slow, so you don't have to worry about these being an obstruction to your spray pattern, but you do have to worry about the fact that it's slow, that whole pocket in there slows the operation of your sprinkler down. And then this was more, again, if you're going to go up above, then you've got maximum of 12 inches, and we will talk about you have to comply with the beam rules here. Perhaps you may need to, depending on the construction type. So maximum, you could just put them up there 12. In this case here, actually you wouldn't in this case here because you're putting sprinklers in each pocket. So the beam rule doesn't apply here. Different types, another different type of construction here, 10 inches deep, 2 inches in depth, you can go 6 inches below here, as long as this isn't more than 10 inches deep, just basically joist construction. This concrete T construction, it doesn't matter how deep it is in concrete T construction, there ain't nothing burning up there. So you can go 1 inch, you have to be, it's basically 1 inch below the bottom of the T construction. Deflector orientation need to be aligned parallel to the ceilings, roof, or the incline of stairs. Installed below the peak of the roof. Deflector needs to be horizontal. If you're going down a peak line, it needs to be horizontal. Roof slopes with 2 and 12 less are considered level, and the deflector can be installed horizontally. So if I've got less than 2 and 12, that's a pretty flat roof, so we can go less than. We can just kind of put those sprinklers in at parallel to the floor below. All right, now we get into some of the performance objectives, specifically for standard spray. Now, I mentioned earlier, there's a couple of different rules that we're using for obstruction when we're evaluating obstructions. And one of them, the first one's called the beam rule. And the beam rule says that the sprinkler deflector can be a certain distance above the bottom of an obstruction, depending on how far that of the sprinkler is from the bottom of the obstruction. So there's a table in 86512 that says basically the distance A governs the distance B. Okay? So what that is telling you is that the spray pattern, is this an obstruction or not, depends on that measurement, A or B. The same thing happens here. If I've got a soffit on the wall, then it's not so much just a straight A and B here, it is more of it's a calculation. A has to be greater than the distance of D, whatever this distance is, minus 8 inches plus B. So we need to know how deep this is in order to make sure that this particular A is greater than that. So if this is, say, 24 inches, and you subtract the 8, that's 24 inches minus 8, and this let's just say this is 4 inches above the bottom, 4 inches from here to here. So 24 minus 8, 16 plus 4 is 20. A would need to be 20 inches away from the bottom of that, at least 20 inches away from the soffit. This here is a simple table. It says if you are this distance away, you have to be this. You can't be more than this distance above. Now, an additional issue on the beam rule here is that if I've got an obstruction between two sprinklers, I got maybe ductwork that's running between two sprinklers, it's less than 4 feet in width, then I simply have to measure from here to here is half of S. And I do the same thing on this side. Okay? So I'm basically treating the middle of this kind of like a wall, half of S. If it's greater than 4 feet, then I have to put a sprinkler underneath that. Okay? If this obstruction is greater than 4 feet, I'm winding up with a sprinkler underneath. So the next point then in the performance objective is A86512. It's in the appendix, actually in the annex of the standard. It says you can have a soffit or an obstruction off on the wall here, like a light or a lighting unit here that's down from the ceiling that actually also could be a planter or something like that. Soffit or obstruction, no additional protection is required as long as it's 4 feet or less off the wall. So greater than 18 inches down, 4 feet or less. What does that sound like? Sounds like that rule that said 48 inches below, you're more than 18 inches down. So anything you're not obstructing the spray pattern getting to the base of the fire as long as you're less than 4 feet wide. The next item that we talk about here as far as obstructions is concerned, when it comes to standard spray pendant and upright sprinklers, is what we call the 3 times rule. Now, the 3 times rule basically says that for sprinkler distance, in order to be considered not an obstruction to the spray pattern, that we take a look at this particular component of maybe a steel I-beam or not a steel I-beam, but a bar joist construction or something along those lines. We take a look at C and D, whatever the greater dimension is. Okay? We multiply that, whichever the greater is, we multiply it times 3, and we say that the distance A, that the sprinkler needs to be that distance away from this unit, this component here, and we don't consider it an obstruction anymore. Okay? So use dimension C or D, whichever is greater. Pardon me?
So let's say D is 6 inches.
Let's say D is 6 inches.
Okay,
And it's let's say 4 by 6 on this one.
okay,
So D is 6.
right,
So what do we got?
18,
18 inches.
so, okay.
Right. So this sprinkler, this dimension here, this sprinkler has to be greater than 18 inches. Otherwise that's an obstruction to the spray pattern. You're going to wind up with a sprinkler on the other side. Okay? Now, we stop that at 24 inches though. You go to the maximum is 24. Now the same thing happens here. Now remember, we talked earlier about that shadow area. Remember? So here's the same thing that apply. Only now we're looking at plan view, and we've got a column over here. Same thing applies here. We could have said that the shadow area was somewhere in here, right? Could have said that that was the shadow area. But we've already said as long as it's 3 times C or D, all the way up to 24 inches, we're not going to worry about that as an obstruction. We're not going to put a sprinkler on the other side. If A were inside this, then we would wind up with a sprinkler over there. So, obstruction to spray pattern development variables. Okay, here's some things that as we're going through this, we need to make sure that we can, we need to consider when we're looking at obstructions. First of all, only consider the structural members in light hazard and not ordinary hazard. You're only looking at the structural members, right, when we're applying these obstruction rules. Sprinklers on the opposite sides of the obstructions take care of the whole thing. We don't have to apply any of those rules if we're going to do that. Location in trusses, if we put them up in trusses in the bar joist construction, we've got to make sure that we're complying with the rules here. Consideration of sprinkler system piping. Is the sprinkler system piping an obstruction in and of itself? If I've got sprinklers on big branch lines, large branch lines, and my sprinklers are sitting on top of them, upright sprinklers on 3-inch lines or something like that, the branch line itself might be considered an obstruction. So, and we apply 86512 for all of those units. Those are where the obstruction rules come in. Now, one of the other things that we come up with here, we've come up against in the past, is an obstruction rule that deals with ceiling fans. Now, this obstruction rule deals with ceiling fans because there's the potential, just like a lighting fixture or anything else, there's a potential that this particular ceiling fan could become or could be considered an obstruction to the spray pattern. Because it's not about this kind of connection right here, this post connection right here. It's the fan unit. That can be pretty big. Or it can be that the paddles, the paddles themselves are so wide that they create an obstruction to the spray pattern. So here's what we're looking at here. If you take a look at just a standard ceiling fan, standard ceiling fan looks something like that. Okay? In fact, it's probably even thinner than that coming out. All right, so basically what the rule is for these are, it says basically as long as it's not more than 5 feet in diameter and it's 50% open. 50% open, you don't have to consider it to be an obstruction to the spray pattern. But what happens when we put these in a restaurant, and it's Joe's restaurant, it's just regular standard old bar fare, and we've got the ceiling fans and they're all set fine, they're all great. All right, and then Joe's goes out of business, and in comes the tiki bar. And the tiki bar wants a whole new motif. And so what do they do with the ceiling fans? Ever seen these? Put the palm fronds on
Yeah,
that overlap each other
yeah.
like that. What have they just done? Yeah, they've just created an obstruction to my spray pattern that didn't exist there before. So it's not only an issue for our layout technicians and our designers, it's, oh my God, the inspectors too. Got to be able to catch this stuff. And I'm not talking about the inspectors from the company, I'm talking about the AHJs.
Which
Well, you know, when you create
ideally, yeah.
change of occupancy anyway, you know, you're gonna-
One would hope.
Stuff, yeah.
Yeah.
One would hope. The other problem is though, what if Joe's just decided to do that anyway? Okay, you don't give a permit for that. So yeah, you're right. If we change occupancy, that's a good time to catch all that stuff. But maybe they just decide they're going to go with this new
You
theme.
may not get a change of occupancy if you get a change of use, if it goes like you said to something.
Yeah.
Odds
So-
are you're not gonna catch it to an annual.
Right. So of much more concern in the 2010 edition of NFPA 13, when I was the staff liaison for NFPA 13, was these large 24-foot diameter foils that called, well, power foils. We'll just use that term for now, because Big Ass Fans was the name of the company that actually raised the red flag here. It became a concern. There was a couple of things that we were concerned about with the large, what are called high volume, low speed fans. And basically these things just spin at a low speed, trying to keep, now probably you have a bunch of them down here in Florida, out in the warehouse, just keeping the air moving. That they determined that you could create a decent, it's kind of similar as a ceiling fan here in your house. It's just keep the air moving and people are a whole lot more pleasant, right? That's really what you're going for there, because they're a lot more comfortable. The problem is, what does this thing do when it comes to my sprinklers? I don't know. We didn't know at the time. What we thought was that it was going to be an obstruction to it could be an obstruction to the spray pattern, especially for ESFR sprinklers, but it could be an obstruction, certainly could be an obstruction to the spray pattern. What we found out is that, no, not so much. That they are not necessarily, they didn't have the impact that we thought they were going to have on either ESFRs or on the standard sprinklers.
That's surprising.
But
Yeah, it
they
was a
are-
bit
they are
surprising.
tied into the
Yeah.
alarm system,
Right.
just because they move air.
Yeah, they move air, so if you get an alarm, they stop, and then they're no longer, they're not an obstruction to the spray pattern. Okay, another place that we need to be concerned with obstructions to the spray pattern are those that grow out of my floor. Okay, they grow up from the floor. So anything that, once again, light hazard only here, but we take a look at dimension A and dimension B, and what we see here is that as long as, that depending on what this distance is, the sprinkler needs to be a certain distance above the top of what we call a floor-mounted obstruction. So one of the things that we'll see though is this does not, even if it's closer and it's not considered, that this doesn't create, you can still get water over the top, and then through that eddying effect, you'll still get water in this back area as well. All right, so this isn't really a shadow area. I mean, it's shadow on paper, but you will get water in there.
So B has to be a minimum, what, 18 inches?
Well, no, B is not a minimum of 18 inches or a maximum of 18 or anything. What it is is you measure it based on how close you, this distance will change depending on A.
Okay.
Okay? So as you shrink A, B is actually going to come up a little bit.
Oh,
Okay, because remember, you're just, what can I develop? It's the development of the spray pattern and getting it over the top of that that obstruction.
Reduce the farther distances. Because
Pardon
the
me?
water's coming down.
No, as you move this way,
No, I mean, as
Yeah.
you get, as A gets longer, B goes down.
B
Because the water's
B
coming
becomes
down.
greater. Yes,
Right.
right.
Okay.
That's exactly the opposite of what I was just describing. I was saying as A gets closer, B gets lesser. You said as A gets further away, B gets
Okay.
greater.
Yeah,
Same thing.
okay. You kept saying it kept going up, I said, why would it go up? You're getting,
Well-
it's into it, but as it gets closer, yeah. Right, okay.
Okay. The other thing we're concerned about here, in kind of similar in its nature, is hospital and privacy curtains. So there are rules and regulations about privacy curtains here. 70% open, 22 inches down from the ceiling. Okay, you got to have it because these will become an obstruction to your spray pattern, just like a shower curtain is. They'll behave just like that. Okay.
Well, you know, on that subject, I don't understand how those big fans would not be considered an obstruction. You know, going back to that, you say, I guess you guys
Right.
check them out.
Yeah.
Because if you guys, with the fans being part of the fire system, like
Right.
it stopped where it stopped.
But
But it stopped right underneath the sprinkler.
Right, but keep in mind that what you got here, we were never looking at the blades. It was always about that ceiling, the motor. Was the motor the obstruction? The blades, especially with those big foils, those are pretty much 50% open, period.
Yeah.
Mm-hmm.
I mean, you're never going to put big palm fronds on those things.
Yeah.
Okay, so what we were really worried about there was the motor. Okay, and how do you take advantage? How do you just ignore it? You put sprinklers on all sides of it anyway.
Yeah.
Okay,
I got you.
so it just never became an issue where we had the research showed that it really wasn't that much of a problem, and we were a little surprised by that too. Okay, so obstructions that prevent discharge from reaching the hazard below. If I've got my sprinklers up above here, now again, we're standard spray pendant and upright only so far. Okay, I got a 5-foot obstruction down below. What's the maximum? 4 feet. 488 inches, 48 inches. So I would need to figure out how I'm going to provide protection underneath there. Conveyor belts are a big issue. How do you get protection down below? Especially over there at the baggage losing facility over at Fort Lauderdale Airport. I mean, they have them. Conveyors everywhere. So some of them are only, now, one of the interesting things is they may only be 3 feet wide in some areas, but they all converge in some location. And so you may have spots where you don't require sprinklers to be dropped down, but then all of a sudden you've got an intersection or a crossover of these things, and now you've got issues where you may be creating something like that. All right, clears to storage. We said this before, 18 inches. Now I want to talk a little bit about ceiling pockets. Now, this is light hazard occupancies, okay? Quick response sprinklers. Now, in each of these cases, you can eliminate sprinklers from the ceiling pocket based on a couple of different rules. First of all, you have to have quick response sprinklers, which in light hazard is easy enough. Okay? Second of all, you can't have any more than 3 feet in depth, 36 inches in depth. Ceiling pocket volume is less than 1,000 cubic feet, each one of these, and they're separated by 10 feet. Let's focus on this rule right here, okay? Because this is the main rule. This is the rule as it was originally written. It said you could have a ceiling pocket here separated by 10 feet from a ceiling pocket here, as long as they were less than 36 inches in depth, 36 inches less, and no more than 1,000. Each one of these was no more than 1,000 cubic feet. Okay? Easy. Easy peasy. However, not so easy was, what if I have these here? Each one of them complies with the 36-inch depth rule. Each one of them is only 333 cubic feet. Only problem is, they're only 3 feet apart. See where I'm going with this maybe, is that these three put together don't equal this. Don't equal 1,000 cubic feet, which is the main rule. So this is what, and yet you have these architectural features all over the place. Okay, you get them grouped, just for effect. So so basically what the standard now says is, as long as the accumulated cubic feet don't exceed 1,000, you can have them closer together, as long as you still have quick response sprinklers down below and it's not greater than 36 inches up. The accumulation of those three in one area is permitted, as long as this whole accumulation of three is now 10 feet from the next accumulation of three.
And you have to have a sprinkler head on each down projection?
Well, you have to have a sprinkler, well, no,
Or is that your spacing?
you have to have your spacing.
Right.
Correct. Now, just for showing it, we put sprinklers in each one, but you might not need to do that.
So as long as it's under 300?
Well, no, as long as I could have 4 of these at 240, 240 cubic feet. I could have 4 of them together, 240 cubic feet.
Okay, but the total volume is 330?
The total volume is less than 1,000 cubic feet.
For the upper one, but for the combination of all 3 of them?
The combination of all 3 is still less than this.
Could it be 4 as long as it's under 1,000?
Yeah, 4, I could have put 4 there at 240 cubic feet.
Okay, all right, okay.
Right? So, okay.
Just the other rule comes back.
Yeah. So now we go to sidewall sprinklers. And I showed you these 3 mainly because this is kind of what you would normally see is the standard sidewall sprinkler. You also have a sprinkler the vertical sidewall, which is pretty, I told you guys earlier that it's pretty rare that you see these. You don't find these very many places. And then concealed sidewalls as well for extra.
I didn't even know that would be
Still.
considered a
The
sidewalk.
one on the
Yes,
right, the other one on the right, we got a nursing home that they have it.
Do you now?
Tenants, the residents use this, they use the pipe as a coat, as a.
Yes. That's why Marriott hotels has on every single sprinkler says don't hang anything in. Because some bride ruined her wedding by hanging the darn, wedding dress.
Well, real quick, and just want to tell this story. I investigated a fire in an apartment complex where a sprinkler system malfunctioned, and sprinkler system went off. A young girl hung her dress up there, so I go in. I'm like, okay, how did this happen? She said, I don't know. I was just in here and the thing went off. I said, you mean to tell me that went off and you had the presence of mind to hang your dress up there after it went off? I said, I don't think so. I said, okay, if that's a story, you think.
I don't know, I was just sitting here and
she tried to tell me that.
I didn't think it would be a problem putting this on.
Like, you put it up there, you set it off without it.
Yes.
Oh.
Yes, you probably did.
Yeah.
No, okay.
So again, we're going to go through similar requirements here, guys. One of the things that you're going to see, so we'll go through these a little bit more swiftly as we go through. But each one of these sprinklers now, whether it's sidewall, what do we got? Maximum protection area, again, all over again. How do you measure it? We're going to show you that in a minute because it's different with sidewalls. But basically you've got, depending on your hazard classification, you've got limitations on your spacing, unless, of course, it's listed for different protection areas. All right? Yes, you can put sidewalls on opposite sides of an obstruction. All right? It is a perfectly legitimate way to do that as long as the obstruction is less than 16 inches or less in width. Once it's greater than that, you got to put one down below. All right? Now, again, with the spacing, it winds up being the L is the distance across the room, S becomes the distance between sprinklers, and half of S is the distance to that wall as sprinklers are spraying out into the building. This is what you were talking about earlier today, I
Yeah.
think. You can put light hazard, again, governed by light hazard or ordinary hazard occupancies, you can put sprinklers on each side, spraying into the middle of the room, 24 feet for light, 20 for ordinary hazard. This can go all the way to 4-inch minimum. You like that? You like that animation?
Toys R Us.
Wait, let's go do that one again.
Okay. You spent how long to do that?
Yeah, it's just a little while.
Yeah.
How do I get it to do that? All right.
Now they
So,
can go back.
yeah, you're right.
Slide.
That's a new slide. Yeah, I know. Anyway, so the distance of sprinklers to the wall is one thing, but then we get to the distance of the sprinklers between each other. Because remember, the same thing happens if you get these things too close. They are not just spraying out into the room; they're spraying down the wall. So if you get these things too close, ready? You ready for it?
Come on.
Here it comes.
Oh.
Put a baffle out there. All right? You put a baffle between them when they get too close, when they get within that spacing. All right, that woke everybody up. See, that's what you need, a little animation. Okay. Distance below ceilings is critical. This sprinkler, never, ever, 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 ever going to operate. Ever. Okay? It just isn't. It's there because somebody said, we need a sprinkler, we need this to be protected by a sprinkler, but it's not. Okay? Did I say never? Ever. It's ever, ever. It's huge. This is a huge vaulted ceiling area. The heat's never going to get down that far. Okay? Not even if we put, which I saw in Pittsburgh International Airport, little nun's hood over the top of it. Okay?
To be a capture.
No. Yeah. That's not going to work either. Okay? It's pretty creative, but it's not going to work either. Okay? It just, you've got to put the sprinklers up. You can't avoid putting the sprinklers up in the glass skylight area. Okay? You just can't. You're not going to get it with that.
We have a building that has an atrium. It has a deluge system at the 4th and 6th floor. They have sprinkler heads on a wall like that, but they're open deluge heads.
Oh, they're open deluge heads. Well, in that case, you know, the detection's going to send them running, and then you're going to have a.
Every month.
Yeah.
Well, what they do is they have the infrared.
Yeah.
The guys that clean the carpet in the rooms.
Yeah.
They run it on the 2nd floor,
Yeah.
come up and they hit the beam. They set that off several times.
So again, with the sidewall sprinklers, again, what we're looking for is also not just from the ceiling, but from the wall itself. Out from the wall, you can go a maximum of 6 and a minimum of 4. You don't, unless you are for the vertical sidewalls. For the horizontal sidewall sprinklers, I mean, you can be right on the wall. There's but a maximum of 6 inches out off of that.
So that other picture we had of the one with the pipe that was on there, that's actually probably too close to the wall.
Well, that one's just fine. Oh, I see what you're saying. A minimum of.
Well, because that wasn't 4 inches.
Right, a minimum of 4. Right, so that was a little too close. Right, that was a little too close. It might not operate for the same reason. You're just not going to get. See, that minimum of 4 is going to allow that air to eddy around it and the heat to provide the operation. Now, again, sometimes we install these on soffits, so we need to pay attention to the width of the soffit here. Again, 8-inch maximum. Because remember we saw the beam, and the beam was 16-inch maximum, we could put them there. Well, that's twice of 8. Look at that magical number right there. Okay, allowable deflector distance to the ceiling, whatever that happens to have been, and then a 4-inch maximum of the sprinkler down to the bottom of the soffit. So that's one of the concerns here. Once we do greater than an 8-inch soffit, we've got to put a sprinkler down below. All right, so what if we have a soffit up above, we're not feeding it with a sprinkler, we've got this here. Well, in this case here, we have the minimum deflector distance to the ceiling and the maximum deflector distance to the ceiling. Okay? So whatever whatever those distances are is what we have to comply with in that particular case. I told you this earlier, mainly because, again, if we had this one coming out parallel to the floor, the deflector, in order to get that spray pattern out, that spray pattern has to go up first. So basically what you would do is wind up with the ceiling being an obstruction itself. Hit here and it would come down the side.
If it's greater than
No,
any.
no. This has to be parallel. The deflector has to be parallel to the line, the ceiling line. Okay. Performance objectives: sprinklers no closer than 4 feet from light fixtures, and then we're going to apply beam rules and 3 times rules. Sprinklers on the opposite side of obstructions less than 4 feet in width. We talked about, mentioned that as well. But again, same general principles. The beam rule, just a little bit different application, because the beam rule in this case is not only going to be out in front of that spray pattern. If I'm coming out into the room here, that beam is not only just going to exist, that obstruction could exist out there, but it also could exist by 2 beams coming out along the side. Because remember, that spray pattern develops along the side. So the beam rule is going to be applied both in front, both in that spray pattern that goes out, as well as the spray pattern that goes down the wall. You're applying the beam rule. Okay. We also have obstructions that we need to be aware of. This is, I think, a 3.5 inch minimum distance now. So this is the problem. So we put a nice big detection device here right next to my recessed sprinkler. My concealed sprinkler right there. Could be an obstruction to the spray pattern development down the wall, unless of course it's greater than 3, I think it's 3.5 inches away from 4 inches away from that unit. So again, just be aware of that when it comes to those recessed, our sidewall sprinklers and obstructions that are non-continuous and on that particular wall. So again, with the you can have a 2x2 obstruction all the way out to the end of the spray pattern here and not consider it an obstruction at all in there. And we have a similar 3 times rule here for the obstructions to spray patterns. All depends on the dimension here, the greater dimension there times 3, and then the A dimension putting you applied to the deflector, the top of the deflector right there. Same thing applies if that's a column. Now we're looking at plan view. 3 times rule applies. Okay, A greater than 3 times C or D. Same thing with a floor mount. So you guys getting it? You guys getting it? Same rules, just applied slightly differently because of the spray pattern. The spray is different. And this is where I was telling you earlier, with this particular device here, you will get less density right in here, but you will get water right in there. Okay, obstructions that prevent discharge from reaching the hazard, continuous or non-continuous. In a horizontal plane, 18 inches below greater than 18 inches below the deflector. Sprinklers required under fixed obstructions greater than over 4 feet in width, and sprinklers are not required under obstructions that are not fixed in place. So if I have a boardroom table, that's not considered fixed in place. It might be greater than 4 feet in width. Don't have to put a sprinkler underneath that. Thank God. Okay, extended coverage sprinklers. All right, so moving on from our now back to basically upright impedance with some also in this particular section it does address extended coverage sidewalls. All the way up to 20 by 20 spacing you can do. All right, starting off with coverage for upright impedance spray sprinklers, we can go up to 400 square feet in what? Light and ordinary hazard. Can't do it in extra, and we can't do it protecting pile storage. We can even do it in obstructed construction, but it needs to be listed for that. All right, pay attention to that. So once again, everything is the same, although D is now less than 30 inches, where before it was less than 24. And it goes up to 30 inches. Same thing applies here. The distance between the two, as long as it's 4 foot, less than 4 feet, you can measure it half of S. Even if it's 20 by 20, you can do that. Big change here, instead of the 3 times rule, it's 4 times rule, and up to 36 inches. Okay? And these, for light hazard only, these distances become greater now. All right? The distance between the B and A now change because it's extended coverage sprinklers. Continuous and non-continuous, same rules Okay? Sprinklers not required under obstructions that are not fixed in place. Sprinklers are required under that. Shielded type of sprinklers may be necessary if they're being used at a lower level, just so that they'll operate. Extended coverage sidewall, similar to sidewall spray sprinklers, except the 4 times rule applies. Okay, so if we went back to all those rules for the sidewalls, same thing applies, slightly different numbers and distances, but a 4 times rule instead of the 3 times rule. Residential sprinklers, basically you'll not find anything specific on the residential sprinklers in the standard. Instead, you will go to the listing requirements for those sprinklers to get all of their maximum coverage area, their maximum spacing, their temperature ratings, deflector distance to the ceiling, installation type, minimum spacing and such. All right, so those, because residential sprinklers vary so widely in their capabilities, you have to go to the individual specification sheet to get that particular information. Use of residential and sloped ceilings, we're going to measure that distance up to the peak, and then S distance between these is going to be X plus Y, but then Z needs to be at least a minimum spacing in accordance with the listing. So if you've got sprinklers on a peaked roof like this, then our maximum spacing is X plus Y, spacing here, and then Z needs to be at least the minimum spacing so that so we're not spraying one on the other. And same thing goes with this particular, even if we're going to a flat ceiling and a sloped ceiling. Seen this before, all right? The beam rule applies, kind of like extended coverage, because remember we showed you the spray pattern looks the same, all right? The spray pattern is the same. 4-foot obstructions, the 4 times rule, and all of the same rules. Okay, so when we get to this particular, as you're moving down, really once you've established in the standard spray and the sidewall, the standard sidewall sprinklers, everything else simply kind of follows that same specific pattern. Nothing really changes except the numbers, the distances. All right, residential sidewall looks a lot like sidewall sprays, looks a lot like extended coverage sidewall spray sprinklers. 4 times rule applies. When you come to CMSA and ESFR sprinklers, however, these are sprinklers that are specifically targeting storage type occupancies. Okay, these are storage occupancies that we're looking at, and these have, especially the ESFR, has additional rules on top of the primary obstruction rules, because additional rules for ESFR, mainly because these are suppression mode sprinklers. These have a job of actually suppressing instead of controlling a fire. So these are highly sensitive to any kind of obstruction. So we do have additional rules for isolated obstructions below sprinklers, continuous obstructions below sprinklers, bottom cords and bar joists, open grates and overhead doors, and special obstruction area allowances. So by the time you get to 8.11 and 8.12, these are specifically geared towards these sprinklers that protect storage occupancy. Now, I'll have you look at this, because in a minute I'm going to show you an ESFR sprinkler. All right, here's a CMSA sprinkler, a Viking CMSA sprinkler. And it's permitted on wet or dry or pre-action systems and installed in accordance with their listing. You're not going to find a whole lot of a whole lot of spacing requirements and obstruction requirements on these, because it's going to be installed in accordance with its listing. Steel pipe for dry and pre-action systems needs to be galvanized, because again, these are typically, well, you can see right here, this is a pendant sprinkler. And so on a dry system, we're going to take extra caution to make sure that the piping is galvanized on that. Non-galvanized fittings may be used, because galvanized is going to what? Resist corrosion a lot more. Corrosion becomes a problem because it settles on top of my sprinklers. Okay, so CMSA intermediate or high temperature sprinklers are installed in specific locations throughout. Storage occupancies, wet systems, ordinary or intermediate or high temperature. Dry pipe systems are typically high temperatures only because we just want to make sure that we're not overtaxing the system by opening too many sprinklers. And in a system like a dry system, it's already penalized by a slow response. It takes time for water to get out there. We don't want to open too many sprinklers while we're waiting for water to get out there. So on a dry system, you have to have high temperature sprinklers. Is that an ESFR sprinkler? Or, oh, kind of looks the same.
Yeah, some components that are different, but that other one was the ESFR, was it?
This is ESFR,
Yeah.
mainly because it
Yeah.
has a fast response link. I mean, the other one probably does. That absolutely is an ESFR, it has to. Okay? So ESFR sprinklers also deliver, these have a different, they may look the same, but they have a different performance for their listing. They have got to provide a dramatic reduction in heat far beyond that which is just fire control, it's fire suppression. Used in wet systems only, unless they're specifically listed for dry, I think there's only one out there that is. The roof and ceiling pitch does not exceed 2 and 12. That's pretty flat, but we simply cannot have pitched roofs. One of the big challenges when you're installing an ESFR sprinkler system and you have a pitched roof greater than 2 and 12 is how do you get it down to 2 and 12? Well, you install typically a false ceiling that is less than that. Installed in unobstructed or obstructed construction, where the depth member exceeds 12 inches, they need to be installed in each channel formed by the structural members. Wow, that can be really a lot of sprinklers. So typically you're gonna try to get them in. What you're looking for is unobstructed construction. Now, one of the big spacing issues here is we can sometimes, once again, you've got structural members that get in the way of our sprinkler spacing. So, and I already said ESFR sprinklers are highly sensitive to any kind of obstruction or movement in the area. So we want to make sure, because we've got up to 100 gallons a minute coming out of these things, we want to make sure that we're getting the total coverage that's necessary. So what we have here is a spacing deviation where typically you're only going to be up to, you're only permitted to be up to 10 feet. 100 square feet per sprinkler. And so here's my sprinkler piping, and here's my structural members. Well, right here, I've got a structural member, I've got my sprinkler right here, and I got a structural member that's not permitted because it's less than 1 foot away from my ESFR sprinkler. Okay, so I'm not permitted, so what to do? What do I do here? Well, I'm allowed to, even if the maximum spacing is greater than 10 feet, I'm allowed to take that one line, those one set of sprinklers, this line, and move it to comply. So I can go 1 foot. So I take it from 10 to 11, I take this from 10 down to 9, and I've still got my 10 by 10. And I'm allowed to do that once.
Once in the building or once in that?
Once in the system, once in my area. Sometimes we use baffles and things like that to protect sprinklers. They are highly sensitive. You can't have them in the design area of an ESFR sprinkler. You can't have them at all. All right, but you can have them separating design areas where I've got an ESFR sprinkler over here. I can put a draft curtain and then use standard occupancy hazard classification protection over here, or non-ESFR protection over in a different area of the building, as long as I'm separating the ESFR design area from the other design area. All right, a clear aisle of at least 4 feet centered below the draft curtain. Sprinkler temperature ratings need to be ordinary unless intermediate or high temperature is required. So the whole idea here is that you collect the heat on one side or the other. What we're trying to do is prevent, by using a 4-foot aisle and a draft curtain down the middle, that we're trying to prevent the heat from one side operating the sprinklers on the other. What you don't want is a fire on the one side where we're kind of using non-ESFR sprinklers to go operating ESFR sprinklers on the other side. So that's really crucial at that particular point. So you can't have draft curtains or anything within the design area, separated within the design area of ESFR, but you can use them to separate them from other design criteria. And here's what we're looking at right here. Standard response spray sprinklers over here, aisle with a draft curtain right down the middle, ESFR sprinklers on this side. Finally, the last item we look at here are in-rack sprinklers. And again, in-rack sprinklers typically don't, I mean, they're basically used, they are sensitive to obstruction, so there are some spacing issues that you're going to have with them, although they're quite a bit closer than others, mainly because their intent is to drive water down into the racks. So what we see here is we've got our ESFR sprinkler system where we've got our ceiling sprinklers up above, and then because of the type of storage and the arrangement, the rack storage, we'll talk about this on Thursday, is that we will have in-rack sprinklers within there in order to deliver water down in through the racking unit. Okay? Because remember, we got to get water to the base of the fire. And if the base of the fire is way down here, it's going to be very hard for ceiling sprinklers to get that water down in between. All right, and so in some cases, we may need to, the standard may require us to put in-rack sprinklers. They're specifically manufactured for that purpose. They have you want to have a guard around them so they don't get damaged, and not necessarily required, but it's important to have a water shield. That's not a heat collector because there's no such thing as heat collectors, but a water shield over the top so that you don't have to spray from above. Cold soldering are in-rack sprinklers. Okay, so we've walked through the installation of the major, the installation rules of the kind of major components of our major sprinkler lines of our NFPA 13. We will talk about in our next session on Thursday on concealed spaces. We will talk about concealed space, specifically attic type and concealed space sprinklers. And we will delve a little bit deeper into storage sprinklers on Thursday afternoon. Tomorrow is inspection, testing, and maintenance conversation we will have for a couple hours, starting at 9 o'clock in the morning, ITM. Hopefully you'll be here. With that, I'm done. We're all set. So, thanks.